Hi everyone. My name is Robert Maboof. I'm a committee member at DLTV and Year 11 IT teacher and the Digital Technologies Learning Specialist, Learning Leader at Wellington Secondary College. Today, it's my pleasure to introduce Paul Croft and his team from Monash Tech School. Today, they're going to guide us through the journey of the Unit 1, the outcome 1 of Unit 2, and show us all the possible innovative pathways that the students can take. Paul Croft has a wealth of experience and a deep interest in promoting innovative solutions within the Victorian curriculum through the design thinking process. So without further ado, over to you, Paul.
Thank you so much. As you might already be able to see, we've got quite a large team here. One of the lucky things I have at Monash Tech School is that we have more tech staff than we have teachers. So we've all worked together to pull this project together. We'll have myself, I'll talk at the beginning. We've got Jeannie, Michael, Glyn and James who will also be talking. There's a few more faces as well that'll pop out. As I talk at any point in time, you can pop questions in the chat, and if they can answer them, they'll try and answer it right away. But also we'll be sticking around at the end to take questions and further discussion. So if you want to come through at lunch and continue to talk us about some of the technologies we share, you're more than welcome to. Today's project, today's PD, I'm going to be talking about Unit 2, Outcome 1 and the Monash Tech School's perspective on it, because it's a assessment that we're really excited about. The thing that I want to thread through this entire conversation is that we as teachers don't need to be experts in every technology that we teach or that students learn. We are supposed to be empowering them to investigate, innovate, and build their own expertise, because that's what they're going to continue to do once they graduate. What you're going to get out of this PD is a bit of a look at the design thinking idea and one particular activity, which is empathy interviews, that I'm going to share that I think are really powerful to improve and take the analysis stage of this task further, as well as a perspective on how to capitalize on the ambiguity of this outcome so that students can really get the most opportunity out of the wide array of things that they can do. And to supplement that, we're going to give 3 specific examples of innovative technologies, talking about what it is, what are the business cases, what's a starting point for your students that you could provide them so they can get kick-started, and then also show you what a project that they could make would look like, so that we can kind of bring these really big technologies down to something that's a little bit more easy to understand, that students will be able to be successful in it. Our purpose at Monash Tech School is to deliver programs focusing on design thinking, prototyping, and product delivery. We really focus on getting students ready for their future employment in the fields that are really relevant in the Monash area. And we also really think about how to help teachers build their STEM expertise and turn some of the ideas that we use in STEM teaching into other units and other curriculums as well. So first one, I want to start with that design thinking idea. I don't know if you've noticed when you've looked through the unit guide, design thinking has been peppered within the study design. The design thinking has been peppered around, but never really goes into too much detail about what you can actually do with it. In Unit 2, Outcome 1, I'm going to be talking Unit 2, Outcome 1 is the perfect place to really start involving design thinking in the VCE curriculum. If you're not sure what design thinking is, that's okay. I've got a really quick introduction here, and there's some more research reading in the resources pack that we are sharing with everyone. But essentially, it's very similar to problem-solving methodology. At the beginning, they've got to understand their target market. Then they've got to figure out what is the problem that they need to solve for their target market, and then come up with ideas. They've got to make a prototype to see if it's going to work, get feedback, and iterate. I'm not going to go into too much more detail here, but I want to show you that it does connect really neatly into the problem-solving methodology. There's a little bit of wiggle room around there, but I really want to focus on this section here, how empathy can really enhance our analysis. We don't use the D School. We use a model like our Monash Tech School model is based around D School and a couple of other ones that our directors and some of the other founding members all worked on together. But the D School is a really great set of links for anyone who's not aware of it to have a look around, and there's some really good resources there. So focusing on empathy interviews. This is the first part, we'd say, in design thinking, where students are actually trying to understand who are they making something for and knowing that there is a problem they're actually solving, not just creating something because they think it's going to be cool. So the activity that I'm suggesting you conduct, and this is what I worked on a lot this year, is empathy interviews, which is when students conduct an interview with someone from their target demographic to explore their experiences, needs, and challenges. We really want students to kind of look beyond their own assumptions and what they think people need, and bring it to, what do actually people need and want. Things I think are really great about this is that it generates usable data that students can turn into their functional and non-functional requirements instead of just guessing. It also gives them something they can use to develop their evaluation criteria. Then outside of, for this curriculum and for the marking of VC, it also lets them build their employability skills, because they've got experience talking to people that they don't know. They've talked about and had to turn these like technical jargon that they might have in their heads from reading the textbook into things that just regular people would be able to understand in conversations. It also gives students a voice to ask questions. It shows that they can have someone that's an adult's undivided attention for, say, 5 minutes time, where that person is going to focus on talking to them, listening to their questions and sharing their ideas. And a lot of students don't have that confidence or that understanding that they are valued members of society and get that time. So I think empathy interviews really build students in those areas as well. Now, here's an example of how you could include this in your school, and this is what I was a part of. So 3 different levels depending on your students, how much time you've got, what your school policies are, things like that. But mock interviews is really simple, where students can take on, or students or staff at the school can take on a character that can be interviewed. That's not quite where we want to go, but it's definitely a step in. A supply client's when the teacher goes, all right, everyone's going to interview this 1 or 2 people that I found and brought in. It's great to allow us to engage with industry, the local community, family members. It's a bit more authentic because the students actually have their mind of, I'm building this for this person, not just I'm making it for an assessment. But there is a decreased autonomy there, which means that the students maybe don't get to choose as much around what project they'd be interested in working for, because a supply client probably has a certain set of interests. I combined this when I was working with Glen Waverley Secondary School. We kind of did both the mock interviews and the supply client, where me from Monash Tech School, I went in as the supply client, but I also kind of adjusted and used my imagination to think about how students' different areas of interests could fit in within my school, so that students could still follow any path they want. The last one, which I think would be really great if you're able to do it with your students, is have them bring their own client in. Go and find someone that they can work with. I think it's really authentic because they've got their heart set on helping someone. It builds networking skills they can take away to their future, such as trying to find a job or when they get a job. But we know it's not appropriate for all students. So there's possibly some mixing and matching you would have to do. Now from here, I want to jump on from not just analyzing the problem, but then once we've found the problem, thinking about what technologies the students can use. The list that they've given us in the study design is so massive, and there's no way that anyone would be able to know enough of that and to be able to spend time teaching students all that to get them ready to be able to choose anyone they want, which is why I want to return to this idea that we don't need to be the experts. We need to be helping students to investigate, innovate, and build their own expertise. One thing that I would really suggest when you're starting to think about, okay, but I really want to know, Paul, what do I need to teach my students to get them ready to do the assignment? I'm really recommending you should be moving towards some more general and flexible tools. Python is used in so many of the different innovative technologies. being able to make a GUI is important for students to do. It doesn't really matter which programming language they're working with. HTML and CSS, so many different things have online components that they can plug into a website if the student's able to make a website. Then the other one is building student skills to learn from online resources independently. When a student comes up to me and says, oh, I need help making this game, Paul, I don't know how to do it. And then half the time I look and I'll go, oh, actually, I'm a little bit stuck as well. And so what I do is I go online, I research, I find YouTube videos, I look at Stack Overflow, I find an online course, I make a bit of progress, I get stuck and go, oh, well, now this thing doesn't work. I go back around the loop again and I continue that. That's a much more real way that we learn and how students will learn as soon as they graduate. It's not, here's the 12 tutorials you need to finish, and then you know everything you need to know about machine learning. There's constantly problems that they need to come up with and solve. And I think this is a great opportunity, not just to build the behavior, but to see and demonstrate that it has been built in previous units and previous years. For my year 9s, an example that I'd give of what I did with them is instead of giving them tutorials after they've ideated and come up with an idea for their game, I set them the task to go and find 3 tutorials themselves online, complete the tutorial, submit it to me as a completed file, and then write a reflection about how is it going to help them? Is it what they needed? Is there some problems still that they need to solve when they get to their actual game? So this is the thoughts that we're going to be working on. The other thing that I wanted to point out within the study design that I think is really useful when we're talking about these really big technologies is that there's this idea of proof of concept. So instead of making a prototype or a finished product, students could also make a proof of concept that's more around demonstrating that their idea is feasible. Doesn't need to be fully developed, doesn't need to be all the different parts working together. It just needs to be able to demonstrate that, yeah, I can do this and I can do this, and we can get some feedback from other people about our idea. It allows us to not rule out these really big projects like blockchain, VR, machine learning, because of the high level of time it would need to develop a finished project. And as we go through with our tech tutorials, you're going to see some examples of how a proof of concept like that might work. But just one really quickly one I'm going to show you here is I've got a student, Priya, who wants to make a VR app. Making a VR app on Unity, that's a lot of work that would go into that to get it to a finished state. However, if we're just looking at it as a proof of concept, she's going, I really want this app to help people with social anxiety be able to visit a psychologist when they can't leave the house. So that's what she's trying to work on. As part of her design section, there's a lot of different things that she would do, but as part of the design section, she might go and make a user experience flowchart that explains all of the different things that would happen when a user gets into it. Then when she gets to development, she can make on Unity using C# a mini prototype that you could use on maybe like a Google Cardboard where you put your phone inside and it shows you a simulated conversation with a fake psychiatrist. A lot less time would need to go into producing that than the full online experience where it actually connects with another person's VR device and there's the voice chat between them. However, it does demonstrate that the idea could work. Then she can take that and do some usability tests, get some people to put it on, talk them through the user experience, have them look through the Google Cardboard and give some feedback about, do they think this would work? And that can then provide them something to use in the evaluation where she can analyze that feedback and say, what are the next steps I would take? And is this going to be worth it if I had the scope to do more? Within the amount of time we have for VCE, probably don't have the scope to do more, but that can be part of the project. Now I'm going to hand you over to my team to give you some really practical ones. As we're going through here, you're more than welcome to pop questions in the chat. They're going to stick around at the end as well. And we've also got a resource document that has all of the different links that we're talking about. So feel free to, if you take that back to school, you could look at it, give some of it directly to students, and we'll see. I'll invite Jeannie now to share her screen and introduce us to augmented reality.
Hello, everyone. Can you see my screen okay?
Yeah. I can see
Yep.
it.
Awesome, wonderful. So I'm going to be giving a brief overview of augmented reality. So to start off with, I'm just going to quickly give a brief definition of what augmented reality is. So basically, the dictionary definition is a technology that superimposes a computer-generated image on a user's view, sorry about the car, user's view of the real world, thus providing a composite view. So basically, it's digitally adding to the real world. So generally, that's through a camera. So you look at the real world, and augmented reality will add something to that digitally that you actually don't have there in real life. So some use cases in business we have in retail, there are augmented reality changing room mirrors that allow you to try on clothing without actually having to put it on, which is really cool, as well as a couple other examples here. Interior design, so IKEA uses augmented reality to be able to add in like furniture or shelves or a table that you want to put into your home before you buy it. So you get to sort of look at it within your home without actually having to buy it, which is a really cool feature. Tourism has made use of augmented reality. So there is a Google Translate AR overview where you download the Translate app and you can hover your phone over a menu or something and it'll translate it from a foreign language into your language in real time, which is really cool. So that's the example there where it turns it from English into, I think, Spanish. And now moving on to entry points for students. So we have two examples here. We're mainly going to focus on Zappar. So this is a both browser-based and downloadable studio application. And basically, it's a really, really great starting point for your students. It's not immediately intuitive. It's a little bit difficult to start off with, but there is a lot of documentation that makes it workable and easy to use once you kind of just sort of use it a little bit. And the free hobby account allows up to 5 projects. So you can start over again a couple of times if you need to, or delete a project or work on it a bit more after you've made your student project. So it's got a lot of flexibility. And the second one is an iPad-based app. So it's iPad or iPhone. Called Jig Workshop, and it's free and easy to use, and basically it's got a lot of pre-built things that you can use to put together your own augmented reality experience, and we have the links for both of these in the resource pack. So I'm going to be going over a quick example of Zappar that I've created, and basically what we have here is the example is sort of to mimic like an art exhibition having a augmented reality area that you scan in and you add and understand and find more information about that particular piece of art. In this case, I have an arcade cabinet, and the little tag on the right-hand side that says arcade cabinet is my, my tracking image. And so when you scan it in, it'll come up with this information section here that you can click on these 2 little buttons here. The laser cutting video is a button, and it'll take you to a video of the laser cutting video, and the more info button, which will take you to more information about laser cutting. So here's a quick video. This is me putting it together, and I did it in under 5 minutes. So I downloaded the downloaded desktop application. I popped into a sample. So this is a image tracking sample. So that's the same thing as using my tracking image. And I download the base, I delete the base project because I'm just using a couple of the pre-programmed things in there to sort of get me started and get things going a bit quicker. So what happens here is I find my image file. So this is the thing that I'm going to be tracking. So that's the thing that's up on the wall that I'm going to be trying to put new information on top of. That's what I'm tracking when I'm like looking through my phone, and that's what will be having an augmented reality thing projected on top of it. So that's that here, and you just add in your extra image, and over the top of that we put our buttons which link up to URLs. So when you tap on those, you can add actions to tap, and that adds your URLs. So essentially you run through it all. It's very, very quick. You have a preview option, and you download the Zappar application on your phone, and you scan this in on your phone. So once you've got that, I have the tracker on my table, and literally the AR tracks it and the buttons work here. So when you select the button, there's the video. I hop out, I click the more info button, so that's tapping, and there you go. Ta-da! So it's quite easy, and it's really, really easy to do, especially with all the documentation that's available. So, whoopsie doopsie. Anyway, so I will now be handing over. That's all for augmented reality. I can't go to the next slide. There we go. Oh, not yet. Sorry. Apologies. Michael, I need to quickly show the last thing. Yeah, I'll just use your screen there. So for augmented reality, there is no real pre-learning. It is useful to know a little bit of Python, Java, basic programming languages. And I found it super useful knowing how to use Unity, because the setup of Zappar is quite similar to Unity. So the way that the actual window is set up. But yeah, that's pretty much all you need to know for augmented reality. I hope you found that useful. I'll now be handing over to Michael.
Okay, thank you very much, Jeannie and Paul. So hi everyone, I'm Michael. I'm similar to Jeannie, I'm a technology coordinator at the Monash Tech School. Today I'm just going to talk very briefly about machine learning, what it is, how it can be used within society and the world, and also how you can bring it into your classroom. So just to start off, I'm hoping everyone can see that screen okay. Perfect. Machine learning is a subset of artificial intelligence. So essentially you're able to train a machine learning algorithm to build a model using a series of training data. Once your model has this training data, it's then able to iterate over that data and make future predictions and decisions. There's a couple of different types of machine learning. The two most common ones are supervised and unsupervised learning. If you're interested in hearing more or learning more about that, feel free to check out that resources document that Belinda's posted in the chat. So where do we use machine learning and where do we come across it? Odds are is that you've actually come across machine learning at some point in your day-to-day, whether that's in your email, your Gmail client or whatever, being able to filter spam emails from legitimate emails. If you've Googled anything today, there's probably a machine learning algorithm behind that, giving you the most relevant results. If you've got a fancy new iPhone or phone that has Face ID, again, that's going to be utilizing some form of image recognition, which sits underneath machine learning. And again, if you've ever had a notification from your bank about mysterious or suspicious activity on your credit card or debit card, you're probably looking at something around fraud recognition and pattern recognition there. So a couple of other advanced uses is that machine learning is currently being used in the medical industry and also in new cars. If you've seen Elon Musk's fancy cars parking themselves and driving themselves around car parks, and it's also used throughout robotics. Diving a little bit deeper into machine learning's use case within medicine, machine learning and image recognition are able to kind of determine whether or not a cancer cell is malignant or benign. So it is quite an advanced use and a very practical use that you can explore. But how do you really bring that into your classroom and help your students actually play with this technology? We've got a couple of examples for you today on a couple of different platforms. The first one I want to talk to you about is a platform called Teachable Machine, and it's a Google project. Teachable Machine is a very simple platform that allows you to easily train 3 different types of machine learning models. The first one is based around images, the second is based around sounds, and the third is based around poses or shapes. The way that this works is that you train your model using a series of sample data. Here I'm building quite a simple little image recognition program that's going to help me determine whether something is recyclable or whether it's just rubbish or trash. So I've got a few different categories. I've got glass, metal, plastic, trash, and cardboard and paper. And within those categories, I've got about 500 sample images of each of those items. I then train my model, and when it's training, it just iterates over that data set a whole bunch of times to determine what the common features of a glass bottle is. It's then able to output on screen. Now that's super handy. You've actually done your whole machine learning algorithm online on Teachable Machines. However, the beautiful thing about Teachable Machine is it also allows you to export your code. Here I've exported it as JavaScript and HTML. And then I've actually added a little bit of basic HTML and CSS. And I've been able to build this live website. So you can actually go to this website here and play around with it as you wish. Just a quick tip, to start it off, you've got to press the home button, and it does take a second to warm your camera up. But what this does now is that it allows me to hold up a material and it'll analyze it as cardboard or paper. And then here I've got a slightly different material, and you can see that it changes what it reads as. It kind of comes up more as glass or trash even. So you can see that my machine learning algorithm behind this isn't perfect. Whether that's an issue with it's probably predominantly going to be an issue with the data set, which is something that I can play with and I can definitely, as a student, improve on. Just to go back to here, there are plenty of use cases for this kind of technology. You could investigate some form of Face ID tracker for when people come and go from your classrooms. I'll let you deal with the ethics behind that. Or you could also look at analyzing whether some detritus in the ocean is a life form or whether it's trash in the ocean. Plenty of different examples that you can use there. Moving forwards, another option that you can quite easily implement in your classrooms is a spam filter or a phishing filter, to be able to kind of do what I mentioned earlier and filter out legitimate emails from spam emails. Here I've used a platform called Machine Learning for Kids. Don't let the name fool you. While it is quite entry level, it does differentiate really well between different technologies and platforms. So your students could start with Scratch and move up to Python. And I'll show you a couple of slides about that now. Similarly with our image recognition software, you do need to train this phishing filter. That's kind of the first step. So that's aggregating a whole bunch of different data sets. Here I've got 500 examples of phishing data and 500 examples of safe data, what a safe email would look like. Machine Learning for Kids is then able to build our model for us, and it actually exports our code. Here I've exported it as Python code, but like I said, it could also be Scratch. With this, obviously you can change your initial parameters. Instead of it being a phishing filter, it could be a fake news filter. It could be, as long as you're able to change that data set, you could actually make it analyze a whole bunch of different kinds of parameters. One of the main things I do want to just mention about all of these technologies is, while they are all online and are quite simple, so you don't require in-depth computing skills, they're great because they allow you to export your code and then build something around that base code. So if you do want to build a graphical user interface, I would recommend that your students will need to have some understanding of HTML and CSS. But if they also want to be adapting their algorithm, then you're starting to look at more advanced Python code. And to render that Python code, you could use a program like tkinter. To talk a bit more about tkinter and blockchain, I'm going to pass over to my colleagues, Glenn and James.
Thanks, Michael. Me and Glenn will be talking about current applications of blockchain, how students can create their own blockchain, and where to find the resources to get started.
So first off, many of you have probably heard of blockchain and instantly think of cryptocurrency or Bitcoin. However, blockchain is the underlying technology behind these networks. Blockchain allows data to be shared by everyone on a network and ensure that data is tamper-proof and can be trusted.
Hundreds of thousands of deaths per year come from food contamination. IBM wanted to find a way to find the sources of contaminated food and its original source. IBM created a food trust where information about food can be shared securely and transparently to create a trustworthy global food supply chain. Blockchain is what stores the information in IBM Food Trust. Blockchain is also used for supply chain verification in BMW, much like IBM Food Trust. Some materials, such as cobalt, come from sources that can be very difficult to monitor, especially in developing countries where there are many mines that are unsupervised. Blockchain enables you to trace a material with the combination of barcode scanning and other identifying technology.
If you have a student group interested in blockchain technology, we recommend this article from DZone. It's a basic article that walks you through how to create a cryptocurrency blockchain in Python. However, with some slight adjustments, you can make it just a general blockchain to store whatever data you want. We've made this mock-up project using blockchain to track the ethical sale of rhino horns in South Africa. We have the underlying code, the blockchain GUI using something like tkinter, as Michael referred to before, and an Explorer website that can be created as a mock-up or as a working model. Here is just a video stepping through this. And it doesn't seem to want to work. There we go. So we start off with the DZone article and putting this code into our own Python creation. With some slight editing, we can make up our own blockchain. It is very easy to link this to a GUI using a library such as tkinter, or if they are using Java, any Java libraries such as Window Builder. Using this, we can print our blockchain in the terminal, and we can interact with this using our GUI. And once we enter our data using the GUI and click submit, we can see, when it comes up, we can see in real time our block being added into the blockchain in the terminal. So now it has been added into our blockchain and we can see the data in it.
Students can also make a website mockup, which will be used to demonstrate how the website will display the data within the blockchain that they created. This is what it'll look like when it's displaying the data.
For pre-learning, a basic level of Python knowledge is needed. However, not much more is needed to get the basic underlying program working. Strong programming skills in Python, HTML, CSS, or Wix can be required to take the project even further and make it more advanced.
So in conclusion, all of these technologies are very new and have a lot of uncertainty around them. Future uses, economic and social impact, and ethics. They're also great discussion starters for students' key knowledge of interaction and impact. We've added some links and articles in the resource pack that should help with understanding what these ideas are. Thank you.
And we'll now pass back to Paul.
Great, awesome. Thank you so much, everyone, for those. I'm just going to stop my screen share because we don't need that anymore. What we want you to take away from this is all of these things could be really great activities that you could teach from 7 to 10. But then when you get to year 11, all of these are also things that students could do and start in their project with the resources that are in the resource pack that they don't necessarily have to have been taught by as a teacher. So we'd really encourage you to work on all that sort of stuff. The other thing that just in general as a tech school, we're really interested in this topic. And if you are interested in going the next level, learning more about some of these, learning about some other ones, we'd really invite anyone to send an email through to us to say, hey, we'd really love to do a PD or discuss it with you further. And in the resource pack, I've put my email down if you'd like to just stay in that discussion. We're going to be just generally around for the next half an hour. We've booked ourselves out to just stick around if anyone's got any questions, they want to talk further about any of the technologies or concepts that you've seen. It is now, though, lunchtime. So I think that is the end of the formal part of this conversation.
If I could just say thanks. Oh, sorry, Robert, I'll let you go for it.
Yeah, I was going to say just thank you, Paul, and the team from Monash Tech. It was a really insightful discussion and it opened up a lot of avenues that teachers can take up or direct their students to. I'd also like to encourage teachers to get in contact with the tech schools in their area. So they're a resource that will prove to be very valuable. As Monash Tech School provides this, we've also got other tech schools that can also provide it for depending on where you live. But again, thank you for all the effort you've put in. It's exciting. It's good.
Thank you so much, everyone.